This video is on the formation of a solution. And what you learned in 10th grade or 11th grade in regular chemistry or honors chemistry was a phrase, like dissolves like. And that works. And that works because the overall delta H for the formation of a solution in which two things are polar or two things are nonpolar, or one thing is ionic, therefore it has charges, and the other thing is a polar molecule, in those cases, the overall delta H is a relatively small value, and so entropy can drive the formation of the solution. You can think of any formation of a solution as involving three delta H's, which add up to the overall delta H of the solution, which could be a positive or negative value. However, you should understand the charges of each of the steps. So any type of formation of solution involves three steps. It involves the solute particles separating. So this is showing you this solute particles here, and they are separating. And they're sticking together originally, meaning that somehow you had to unstick them. And for that reason, the delta H of the separating out the particles of solute from one another has got to be a positive value, because once again you're separating particles that are stuck to each other. If you're doing that, whether it's pulling electrons away from atoms, pulling ions away from each other in ionic crystal glass, separating water molecules so the ions can go in between, whatever it is, at some point you're separating the solute particles. That's going to have a positive value for the delta H. Now, the separating of the solvent particles, so you can stick the solute particles in between, will also have a positive delta H, because once again, let's say if the solvent is H2O, you've got to break those hydrogen bonds, right? If the solvent is an organic solvent, let's say it's acetone or hexane. Hexane is a 6-carbon ring. It's really important in organic chemistry. Formula C6H6, and it's pretty much a nonpolar molecule. If you're going to separate out those molecules, you've got to break the London dispersion forces. Because you're separating particles that are attracted to each other, it's an endothermic process. So the delta H1 and the delta H2, which are the first two steps in the formation of a solution, will always be a positive value. The third part of the process will always be a negative value, and that's because if a solution is able to form, right, the assumption is that the solute and the solvent are going to be able to stick to one another. That means they must have an attraction for each other, some sort of coulombic force of attraction. And if in fact that is going to happen, then those particles are going to move closer to each other. And when particles that are attracted to each other move closer to each other, energy is always released. So you have three processes, two of which are positive and one of which is negative. Now sometimes the formation of the solution is positive or negative. If you were in my class in 10th grade, I might have shown you the dissolving ammonium nitrate. Ammonium nitrate does dissolve. It's very soluble. And when you hold on to the test tube, if I put some NH4, NO3, and I put this solid and I put it into the water and make it AQ, and so now it's in the test tube, and you put your hand around the test tube, right? This is my great diagram here. That's your thumb, by the way. If you put into the test tube with the water, it will feel cold. And it feels cold because it's taking heat from your hand, because the process of dissolving ammonium nitrate overall is an endothermic process. If you dissolve an acid in water, no matter what the acid is, and these are facts that show up sometimes in the AP, that's why I'm mentioning them, right? You should know whenever an acid dissolves, it's always an exothermic process. Always. That's why there's rules for adding acids to water. Like, you never add a little bit of water to acid because it will splatter everywhere because it's very exothermic. And if you're not wearing your goggles, you can burn your eyes out. So you always add the acid to the water, and you add it very carefully, slowly, and patiently. It's always exothermic, so the solution always gets warmer. And that's because overall, when you add the positives and the negatives, you either get a negative value overall or a positive value. Just because the delta H is positive and negative does not tell you whether or not a solution is going to form, because in the end, as long as the positive or negative value is not extremely large, like it's extremely endothermic, exothermic, then entropy, or the delta S, which is always increasing during this process, will make the overall value of delta G a negative value, and therefore the solution will form. Now, I'm only bringing this up right now in AP Chemistry because I never covered it, and it's one thing I think you should know and be aware of. It doesn't show up in my test, but I hope you're watching my videos. So, if you look at this diagram right here, it basically says this. If you have a polar solute and a polar solvent, it takes a large amount of energy to separate those guys because they're really attracted to each other. Right? However, since the individual solute and the individual solvent are both polar, they're also attracted to each other. So the solute particles are attracted to the solute particles, the solvent particles are attracted to the solvent particles, but the solute and the solvent particles are also attracted to each other. So you get, and when they form a solution, you get a large negative delta H for that. Now, what the relative values of these things, these are both positive and these are both negative, is the question is how much do they cancel each other out? Well, sometimes the negative value here is a little bit bigger than the two positive values, sometimes vice versa. But because all three of them are large, they kind of cancel each other out. So you get an overall delta H that's a small value, and therefore the solution will form. And that's really why like dissolves like works. Because when you like dissolves like, it means that the delta H's in the separations and the formation solution essentially negate each other to a great extent, and therefore the delta S can drive the formation of the solution, and it will form. And that's why like dissolves like works. Right? That's why when you have something like a small, if you have this and this, right? If you have a nonpolar solute and a polar solvent, the attraction between them is very small, and so the overall value of the delta H is going to be positive. It's going to be really largely positive because it's going to take a lot of energy to separate, okay, the polar solvent molecules. It could be water molecules, and this could be like, let's say, I don't know, oil. You know what I'm saying? And this could be, let's say, water. It's not very difficult to separate the water particles, the oil particles, but it's very difficult to separate the water particles. That means the delta H for that process of separating those out is a very large positive value. And so, since these two really aren't very attracted to each other, the energy released when they form the solutions would be very small, and therefore the overall value for this process would give you a large positive delta H, and because of that, delta S is not enough to drive the reaction and no solution forms. If you have a nonpolar solvent and a nonpolar solute, everything is small. They kind of cancel each other out again. So oil will mix very well with, let's say, hexane. Hexane's a nonpolar solvent. It doesn't take much energy to separate oil molecules. It doesn't make much energy to separate hexane molecules from each other. And not a lot of energy is released when you mix them together. But overall, the delta H is relatively small. So once again, entropy can drive the reaction to occur. So, like dissolves like, polar solutes dissolve in polar solvents because the overall delta H is a really small value, because the three processes overall cancel each other out. Nonpolar, again, small. They kind of cancel each other out. Overall delta H, not very large. If it's a polar solute and a nonpolar solvent, it takes a lot of energy to separate the solute particles from one another. It doesn't take much energy to separate the nonpolar solvents because they're not very sticky. However, they're not really attracted to each other, so the amount of energy that's released in the delta H3 is relatively small. So you end up with a large positive value again, and so therefore no solution forms. In both the cases where no solution forms, the thing that really is at the end of the day means it doesn't happen is the fact that the overall delta H is a large positive value for those, and therefore entropy will not drive the reaction. Now, that does not mean delta H will not be positive sometimes when the solution forms. That clearly is true. However, it's not a large value.